Okay, my friends, this is the first unambiguous dormant black hole. And what is a dormant black hole versus a regular black hole? Well, a dormant black hole means it's not spinning and, ripping through the galaxy and so forth. It's just sitting there, dormant. It's not doing much. It's a black circle with white surrounding it, because these are the charged particles that surround it. Now they're showing that it must be moving, because these are more interactive, so it must have some spin to it or pushing through, but it's not 100% dormant. If it was, it would just be a complete, solid, perfect, same color ring around here. Now, I can also show you a black hole that was created in space by the Russians in 2015. Okay, I'm going to show you something. This is kind of funny. I'm going to show you the black hole that the Russians created in space, which flipped out a guy from Max Planck. He was locked himself in his office for 3 weeks after seeing it, because they couldn't figure it out. They still never have figured it out. I am going to explain it. Now listen to this. Take the solar system, put a black hole where the sun is, the sun where the earth is, and you get this system. Explained Kareem El Badri. He's the top, or she, I don't know, whoever it is a top physicist here, an astrophysicist at the Center for Astrophysics, Harvard, Smithsonian, Max Planck. This is the one. Institute for Astronomy, and the lead author of the paper describing this discovery was published on November 2nd of 2022 in Monthly Notices of Royal Astronomical Society. Well, I have something to say about this, because, they're talking about an unambiguous detection of a dormant black hole and so forth. Well, I'm going to show you a black hole, and I'm going to show you how it gets created, and it does look just like they're showing here. Basically, it looks just about like that. Only you can't really see through a black hole. The black hole does not absorb, it does not reflect, and it does not emit. All right? So it's just black. When you look at it, all you see is black, but you can't see through it. I'll show you. I can pretty much prove that. Okay, my friends, this is a trip down memory lane, and this is going to be exciting as hell. It is for me. I was studying light. Now let me show you the particles that I saw, and they are plasma, so I started looking into plasma. And this is plasma in space. Now this goes back 9 years ago. Okay, so what is plasma? Well, plasma physics is the study of charged particles in fluids and in gases and any charged particles interacting with self-consistent electric and magnetic fields. The fields are the charges that surround the particles. Okay, that's why they're charged particles. It is a basic research discipline, has many different areas of application: space, astrophysics, controlled fusion, which what we did, accelerator physics, beam storage, all of that stuff we did. Now, let me show you this. This is University of Colorado, Boulder. All right, just so you understand, these are charged particles. It's quite obvious that one of them is a glowy burner, and one of them is it never changes size. It's a fixed particle. They know this from Fermilab. This is from Fermilab. It's called "What's the Point?" There's an article by Don Lincoln. We see these exact same particles, and one can get glowy and one can get less glowy. It's correct. These never change in size. These are always the same size. And they will not allow themselves to go through the venturi that we created. All right? This particle beam is going straight to that venturi, and when it does, the particles separate. And instead of being the black and white attached together, which normally the muon, electron, neutrino are glued together, gluons, they broke apart here. At light, though, they're photons. An electron is half of a light particle. A photon is 2 electrons, just like bar magnets, back to back. See? This is the same particle. It's just this shows the energetic values. And it is the exact same particle they found at Fermilab. So it's and CERN and all of them. Only here's what happens. We need controlled fusion. That's what we do. they are exploding things. They're banging them together and everything's just flying everywhere. And they see these two particles, which are the two at the top. Yes, absolutely. And they're the tiniest ones they can see. Yes, absolutely. And this one is a bowling ball. It never changes size. Yes, absolutely. And this one here is a burner. It has virtually no mass. Yes, absolutely. I agree with all of that. We see them from our light experiments. Now, so we're working with light, not protons. Light is those little tiny particles, which are photons. And there are nothing but photons and those two little particles that exist in the whole universe. That's all there is. This is the new dipole flood theory, dipole electron flood theory. Everything is nothing but made of these two particles. There's nothing else. But I think there's excess black ones. There appears to be. And that's why we get these black holes. And the white ones surround them as charged particles. Let's look at that in space, because the Russians did that. But this is fission, when we broke apart the white and the black. And this is coming back together as fusion. In between is raw energy. And I think we can get a hell of a lot of return for our money, because there's no... This is cold fusion. This is the holy grail. And that's what they're looking for right here. Muon neutrino attached to the electron neutrino. When they come in and they create Cherenkov radiation hitting heavy water, they split. The muon goes on its way as like the black ball, and the electrons turn into showers. Exactly what I'm showing. All right, I'm going to explain this. It's in Russian with subtitles, so I'm just going to explain it to you now. They're in space, the Russians. They have a vacuum chamber. Now, a vacuum chamber is nothing more than a enclosure, whether it's a box or a bucket or a tube or whatever it is. And they suck everything out of there, so there is no gases, there's no dust, there's literally nothing in there, which means it's a vacuum. That's what a vacuum is. There's no particles. No. They don't understand or consider the fact that on the walls of the container, they're saturated with electrons, which are pushing in from all the sides. There's nothing in the middle right now, because they got a vacuum out, so there's nothing there. Then they're going to let in these charged particles. A charged particle just means it has an extra electron. All right, just like static on you. It wants to jump. It's got power. And if it pushes against another one, they're going to glow. That's what happens when light or any energetic particle pushes against another energetic particle. You get a glow. And that's what they're going to see. You're going to see the glow start to enter. And then you're going to see something that blew everybody's mind. It's a black hole. So I'm going to let this play. And this is SBOBC. And this is from like 9 years ago, I think it was. Yeah, 9 years ago. And at the same time, we were doing research on light, and about 2015 or so, I started to, I finished the theory of what these particles are, and how they react, and what black holes are, and they are nothing more than the dark particles collecting, which can separate. I've shown them separate. Okay, and the thing I just showed you, I believe I showed you that the white can separate from the black and then instantaneously comes back. Now, in outer space, it's a little different, I think. I think it can go to the center. Now, normally everything spins in outer space, but in this black box, they're not going to have any spinning, and this particular black hole they're talking about, they say is dormant. That means it's not spinning. So, let's see what happens in this vacuum chamber, which means there's no particles whatsoever in there. However, it's inside of a box, and that box has a liner around it, and every surface is coated with electrons. So there is some push from both ends and from top to bottom. And it appears to me that what they're going to show you is that the top and the bottom are closer together than the ends because of the form of the black hole. Now, get ready. All right, now this is from a channel called SBOBC. Now, this is 9 years ago this was done, and this it's funny because Max Planck is, that guy from Max Planck is the one that freaked out. And they're back thinking about black holes again. All right, here we go. These are the Russians now. So this is their black box, which is a vacuum chamber. Now, I'm going to stop it here and there. You see what's coming in? Every glowy particle is a charged particle attached to a micron-sized particle of dust. So they're extra electrons. Electrons push other electrons. You see them forming lines? That's what the interference patterns are, because they don't like each other. They push each other away. They'll separate into lines. Now they're pinching forward in the front because they're entering into here, and there is some push from the walls. They're pushing it in. So they're pinching that nose to be a point, and these are turning into strips of electrons. Just keep watching. Here they come in. Look at them turning into regular little streams. Now, they're watching in here. Now, what they expected to happen, I'm going to explain to you. What they expected to happen was all these particles push each other away. They knew this was going to happen. And they expected a lattice form to come in here, like all lines, and each one of them pushing away like, you know, like this and like that. So that they're all like in boxes, but every one of them is like a corner of the box. Think of it that way. But instead, this is what happened, which freaked them out. Wait a second. Let me put on closed captions. All right. Let me come back to here. All right. Let me come way back here. All right, here. They're in outer space, which means there's zero gravity. So nothing's trying to crush the particles to Earth, because they do. They get sucked to Earth. That's what gravity is particles being sucked to the Earth, just like they're being sucked to this black hole that you're going to see in a second. Black particles are gravity, and I showed you our black and white particles. The black ones are the gravity. Now, this is a vacuum chamber, and it has a regular vacuum in here where there's no particles whatsoever. And outer space is not like that. Outer space is filled with particles. But this one, they've taken every little tiny dust particle out. Now, so here's what they're going to do. It's got a full vacuum in it, and they're in zero gravity. They got a real powerful computer looking at this stuff. Now, plasma is first created in this black bucket chamber. Now, then they inject it into this vacuum. Now, you see all the lines striping out there? Here it comes in, here it comes in, here it comes in. And now they're looking at all the formation of these particles, expecting to see the lattice and all of them separated from each other, but it didn't happen. The black hole started to form in the center. First thing, it all swirled, and they all pushed and shoved, and some were attracted down, and some, you know, just floating around. It appears that there must be some form of a little bit of gravity to them. All right, so everything was happening in the black bucket. They received data was completely unexpected. Now listen to this. This is about the Max Planck guy. Instead of cleaning this lattice, which they expect, this is what they saw. Empty void. Now watch. I want to show you something. I'm going to play this very slow so that you can see the bounce. Playback speed. Let's go 25%. Now, watch this. Here's what I'm telling you is the reason you see this elongated tube. It's not a perfect round. Why isn't it perfectly round for a black hole? The reason is the walls. All right, the walls of the chamber were closer here than they are on the ends. So it's not pushing the stationary particles that are in the walls. It still have the same push, and they can't move. So this is going to bounce against and bounce back. Bounce, bounce, bounce. Same thing here. Bounce, 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 bounce. Well, if it's closer, you're going to get more bounce. You're going to get a flatter circle. So let's watch it bounce. You ready to bounce? Here we go. boom. See it? Boom, boom, boom. They're bouncing up, coming back, bouncing up, coming back. And they're settling in on, look at it, it's just boom, boom, boom. And it's settling in on this black hole. Now listen, he says, during the experiment, we contacted the Earth guys who couldn't believe it either. Everybody's freaking out seeing this. They say, haba. I think somebody said that. I can't be certain of that, but I would have been saying it, I can tell you that. Now, so here's what happened. They're watching it. All right, and it's bounce, 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 and finally it settles in. It says one of the scientists from Max Planck Institute told us that upon receiving the data, he locked himself in his office for several weeks. And they still don't know what caused this. I know exactly what's causing it. It's the push to shove of the electrons. They can't figure it out. We got a lot of data observing the behavior of the particles, but what did they do with it? And then they're showing all of the different interactions between this black hole. Very, very interesting. Plasma in Space Experiment, English subtitles, it's called, on YouTube. All right, here's some other formations they found inside this plasma. You can see it's setting up these patterns exactly like the galaxies. It's pushing and shoving. That's why you have black between the whites. Black between the whites. The black, it wants to pull the whites together. The whites want to push each other apart. All right, now I'm just going to let this play through. This says the mini galaxy can be used to study formation of real galaxies. You see it? That's why you got these push to shove, push to shove, push to shove. These are spinning, and they, hold on a second. This needs to be seen better. All right. What they're doing is, every time you see white, that's glowing more. That means it's pushing something harder. These are pushing each other, creating the black zone between. Now, watch this other one. This one other was very illustrative. See it? Now, as this white comes back this way, it can't, this is pushing it away, so it curves itself in. That's what causes them to spin. The white's pushing against their own self. You see it? It's pushing, boom, push it. See it? It came up and said, no, 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 you go down that way. And it's coming down, and this is going to say, no, 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 you go that way. See it? See it? Boom, boom. And now this is, I'm not sure what the hell that is, to be perfectly honest. These are some kind of plasma cooled. Oh, okay, this is where they're cooling it. It looks like DNA. Look at this. This is, hold on. That's DNA looking. These are the cross sections of the DNA, and that's the helix. Now, cryogenic, listen to this. Cryogenic means very cold. So, if the plasma is cooled cryogenically, a DNA-like shape appears. That must be this, what they're looking at here. Hold on. See it? They got the box around it, and then they're showing this. I can imagine that's what they're talking about. All right, and then they go on about some other stuff, but this is pretty interesting stuff. And I believe that is the first black hole that's ever been seen in space, or has ever been actually created. And there it is right there. Now, one last thing. I told you before, you can't see through a black hole. It just looks black. And the reason is, it doesn't absorb electricity. Well, wait a minute, hold on a second. All right, I have a problem with the way they define a black hole. I say a black hole, they say it doesn't emit, it doesn't absorb, and it doesn't reflect. I believe that's the statements that they claim about a black hole. It does not emit any energy, so you don't see anything come. It's black. It doesn't absorb anything, so energy just flows around it, basically. And it doesn't reflect, so it doesn't bounce back. It's an absorber. This is an absorber of light, and this is the way it absorbs is around its outside edges. Now, if it's in motion, that's different. In motion, you've got a whole array of things and gases and so forth, and especially when it's into a gravitational field like Earth or the Sun or any body that has mass. Out here, this is a whole different story. In the zero gravity of space, there's no real vacuum. There's no real vacuum. But that's okay, because you want a bunch of particles to be floating around in space to create these black holes. If you didn't have the particles, the black hole just would be nowhere. It'd be all by itself. Everything would be a black hole. So it's good that these particles are in the vacuum of space that they never considered before. And they are light particles, just like I showed you. They're energetic little particles. And they want to find these black particles to attract to. And they call that the quantum foam right now. And every now and then you have a big bubble in the quantum foam. Instead of little tiny foamy bubbles, you have a big one. That's what it appears to me right now.